we started by looking at a basic control system where we have the controller, for instance, in this feed-forward system, right? Where we had the controller measuring what the output was, and then use that to compare with the set point, and then determine some kind of manipulated input variable here, which now goes into the process system, right? We talked about how feed-forward exists. It may not be as effective, but feedback systems are always usually incorporated with feed-forward systems. A good example can also be seen, for instance, now you have your air conditioner, right? You leave your air conditioner on, you probably reduce the temperature to 70, 78. If you live in the south, you go to work, you come back, and you just feel it's exceptionally warm, and you change the set point on the air conditioner, right? Because you have some kind of offset in your environment when you get there. So, but then the temperature of the system has to adjust. It has to find a way to adjust to that 75 degrees, but it may be plus or minus, right? So that's kind of like a feed forward. And if you're not still comfortable with that temperature, you go back and you change it, right? But just envisage a scenario where you have sensors placed all over your apartment, and your air conditioner is able to adjust itself to get the exact temperature that you had set it to be, right? So that's going to be like your feedback. Your sensors keep feeding back to the system to adjust its input or the temperature so that it gets you the temperature you actually want. So that's kind of how you want to place in the morning for how feedback and feed forward works, right? And it makes sense to think that a feedback system is kind of more effective because it helps you to adjust automatically, right? We talked about a couple of definitions: single input, single output. You can have multiple controllers working in the system. When you have your master and your slave, where you have the output of the master being the input for the slave controller, and then the combined controller output is now used as a manipulated input for the process, right? Most times when you have cascade controllers, which are multiple controllers, they usually help you to adjust the offset in the system better. Any of those measurable or immeasurable disturbances that get into the system, when you have controllers in series, they kind of help you out, right? So we talked about cascades. We talked about dead time. Usually the death of feedback systems is this dead time, right? Because it takes time for that disturbance to actually manifest in the system. And so it takes a while for the system to realize that, okay, I'm not getting the correct input variable. So it takes a while. So usually feedbacks suffer from this. But yeah, it's something that process control optimization has dealt with. That's why if you employ, of course, a PNID system, once you know what the error is for PNID system, remember we talked about the proportional controller, in which the controller output, right, is going to be proportional to the rate of change of the error signals. And then for the integral, it actually, the controller output is going to depend on the error as well as the amount and duration. So it's going to be the amount and then the duration of the error signal, right? So the integral usually is always paired up with the proportional, because for the proportional, you always end up having some kind of offset, some steady state offset, right? It's unable to factor in the fact that disturbances happen over time and it doesn't accumulate those instantaneous changes over time. It just assumes that the error is calculated at that set point, and then it tries to adjust for that particular position. And then meanwhile, the disturbance keeps happening over time. And so that's why you need to pair a proportional controller with an integral controller to kind of deal with that steady state offset. All right. So set point definition, you guys have used that so many times. I'm sure you've pretty much figured out what that means. So we talked about how select measurement methods that are being used, electronic, pneumatic, and then sometimes they use light. And the measurement variables, so when they make questions on control, they're always either dealing with composition, temperature, pressure, liquid level, flow rates, all those kind of stuff, right? So for us solving problems or looking through, for instance, the homework problems and additional complementary material would help us kind of get used to how these questions are usually framed,